The oil and gas industry is one of the most famous and well-known industries in the world, producing natural gas and crude oil to fuel our daily lives. Crude oil and natural gas are found underground and brought to the surface by drilling and extraction, then transported to a refinery, which converts the extracted raw materials into numerous usable products for consumption. In order to transform crude oil into numerous usable products, the industry makes use of a variety of mechanical components that help in the extraction, transportation, storage, and refining of the extracted raw materials. Piping and equipment are the most common components seen across the industry, whether in the upstream, midstream, or downstream work sectors. These piping and equipment are commonly insulated with thermal and acoustic insulation systems, which allow for the successful conversion of crude oil and natural gas. The primary role of insulation in the oil and gas industry is to keep the process temperature stable, conserve energy, and prevent condensation. Additionally, it protects personnel from thermal burns and noise pollution, as well as contributes to a reduction in carbon emissions. This educational video from the Institute for Oil and Gas Sector delivers insights into the thermal insulation used on equipment. The video's learning objectives include important information required before commencing insulation work on equipment, essential documents that must be adhered to during the insulation work, installation challenges, strategies to address CUI issues, and the 5 key factors to consider for achieving optimal performance from the thermal insulation system on equipment. So, what is equipment? The term equipment in the oil and gas industry refers to large diameter columns, exchangers, massive vessels, tanks, and similar items. The substantial dimensions of these large diameter structures present unique challenges that are not typically encountered in pipe insulation applications. The equipment used often varies in processes, temperatures, sizes, lengths, and other characteristics. Therefore, the installation requirements and practices are customized for each piece of equipment that requires insulation. The equipment drawing and the project installation specification include all essential information needed for the execution of insulation work on the equipment. This means it is important to read out these 2 documents to understand the relevant insulation system, operating temperature and materials, required insulation thickness and properties, application guidelines, applicable standards, and other aspects. Adhering to the specified requirements from the drawing and specification during work execution is a must in achieving the desired result. The desired results and optimal performance from thermal insulation involve multiple factors to consider, not only during the execution phase, but also while designing the equipment and writing the specification. 5 of these include ease of access, well-designed support rings, minimal protrusions, thermal expansion concerns, and mechanical protection of insulated equipment. Ease of access is one of the most important factors to be considered during installation work, as the equipment can range in height from 5 feet to over 150 feet. This indicates that the majority of the insulation will be installed from a scaffold. Therefore, it is important to build the scaffold in a way that enables the applicator to insulate the equipment properly, while ensuring that the insulation of the equipment's body or head is not compromised by the required insulation thickness. The second factor on the list is the use of proper support rings. The insulation support ring secures the insulation's position around the equipment body, preventing it from sliding due to gravitational forces. The support rings are often welded to the equipment body during fabrication. Concerns about the support ring include its width, which should allow the insulation to sit properly. It should also be designed in such a way that water does not accumulate within it, rather than allowing proper drainage in the event of water ingress into the insulation system. The third consideration on the list is protrusions, which includes structural or lifting supports, manways, nozzles, anchors, and the like. These protrusions are welded to the equipment body and the head, resulting in additional cutouts within the insulation system, presenting challenges for applicators during insulation installation, while also promoting corrosion under the insulation, as they often allow water or moisture to infiltrate infiltrate the insulation systems through the cuts or joints around them. Therefore, the equipment designer needs to minimize the number of protrusions extending from the equipment body. This allows for the continuous installation of the insulation system without interruptions or cuts, thereby reducing the likelihood of corrosion under insulation. The two images on the screen represent insulated equipment. When you compare them, you will notice that the equipment on the right has fewer protrusions than the equipment on the left. As a result, the installed insulation system appears to be uninterrupted and continuous to the equipment on the right side, resulting in fewer joints in the jacketing and making the insulation system more effective in terms of performance and fighting against the CUI. The two arrows represent the example of joints that normally develop in the insulation system due to the protrusions from which the water ingresses and initiates the CUI. Thermal expansion is the next important factor to consider when insulating equipment in the oil and gas industry. It is a phenomenon that designers must consider when designing the insulation system. This ensures that it can effectively accommodate the movement of equipment caused by heat. This is achieved by installing the expansion or contraction joints beneath support rings and incorporating springs with the bands within the insulation system. As a result, it is important to ensure that such joints and springs are installed in accordance with the specifications, allowing the insulation system to expand and contract without breaking during thermal movement. Mechanical protection is the last consideration that comes after the equipment has been insulated with the specified insulation system. Mechanical protection refers to protecting the installed insulation system from its surroundings. This includes protection against any subsequent activities that may occur after the insulation work is completed, as well as preventing walking on the insulated items. While the insulation system is designed to be weatherproof, it is not bulletproof. Therefore, stepping on the insulated equipment must be strictly prohibited. A mechanically protected insulation system works effectively because its jacketing and insulation remain intact around the body of the equipment, allowing it to perform its intended function. On the other hand, if the equipment insulation is not mechanically protected, the system's integrity will be compromised by broken insulation and jacketing, allowing heat to travel through and water to ingress into it, resulting in CUI possibilities. So, taking all of these aspects into account allows for optimal thermal insulation performance on the equipment. And we hope you found this video tutorial useful. If you enjoyed it, we'd love for you to give it a like, write your thoughts in the comments, and share it with your friends and colleagues. We also encourage you to subscribe to our YouTube channel for more insights on the oil, gas, and petroleum industries. Furthermore, if you want to find out more about the thermal insulation or the thermal insulation training and certification courses offered by the Institute for Oil and Gas Sector, please visit the Institute's website or write an email with any inquiries.